It is 2024 and I really hope that you are using only TypeScript for all your projects and not JavaScript. And it makes a lot of sense because it is safer, easier to understand and your code is more reliable. So if you plan to build a REST API in Node.js, it makes a lot of sense to use their TypeScript also. This is why by the end of this video, you will learn how to do exactly that and how to set up TypeScript together with Node.js and implementing authentication and managing users in this API. This video is brought to you by Bicepta. And one of the most popular products of Bicepta is Mock API, which allows us to create a fake API in a matter of seconds. We just need to paste here our JSON and select the URL that we want to create. Here the response is 200 and we're clicking Create Mock Server. Now we can use this URL with /articles to get access to our mocked list of articles. Additionally, we can configure different rules, for example, when we need to simulate a delay. Now we will get our articles only after 2 seconds. To try it yourself, check the link in the description box below. With that being said, let's jump into the video. Let's look on our initial project. Inside package.json, we have a node daemon source main.ts. If you don't know what is node daemon, this is a tool which will restart our web server after every single change. And in order to install it, you can write npm install -d node daemon because we need it only in development. Also, here is our TypeScript config, and we have a TS node line inside our dev dependencies. It is needed for node daemon to work with TypeScript. And now inside source main.ts, we have our super small Express application, which does not do anything. This is why in the console we can write npm start, our server is started through node daemon, and we are getting API is started, and as you can see it is being started on 3012 port. And we will implement here an API, but I don't want to use a database. I want to show you how you can easily use a simple JSON file in order to implement a database. And this is what a package like JSON server is doing for us, but we can implement it yourself. This is not that difficult. As you can see inside root, I have a db.json file, and inside it's an object with just property user, which is an empty array. So here we will store all our users. But you might want to ask, okay, but if later I will have maybe products, then here you will create a property products, and it will be an empty array, which actually means this single file is your whole database, and we will update it. Also, as you can see here inside source, I created a folder users with 2 files, user router and user database. They are completely empty, but the main idea is that inside main.ts we will use a user router, and this user router will have all routes which are related to our users. This is why our first step would be to create here our user router, and we're using here express.router. This user router is completely empty, but inside our main.ts we can now register with app.use on / this user router. And the main point is this user router and everything about users is isolated inside users folder. Our main.ts doesn't know anything about it. We simply import here user router and we're good to go. What we can do now is register all our routes. So we can write here user router.get, and for example we want to implement /users. What I want to do here is to get request and response from Express. And now here as a second parameter we have an async function where we're getting request and response. And inside just for testing we can write something like rest.json users empty array. Now we can jump inside Postman on localhost 3012 /users. This is a GET request. I'm hitting send and we got back an empty array, which means this route was triggered and we configured everything correctly. As we're using TypeScript, we must create all our entities with types, and we must understand what interfaces and types we need for our application. Inside root I created types.ts, and here we can already prepare several types that we will use across our application. First of all, here it will be a type user. This is our main entity that we will work with. Here first of all we have an ID, then we have a username which is also a string, an email which is a string, and password, which is obviously a hashed password, because you should never store password without hashing. This is not a safe approach. Additionally, here I want to create a type for our database. Just to remind you, inside our db.json, we have this object, and I would like to cover this object with data type so we know what data we're talking about. This is why here let's create a type db, and as of now we have just a single property users, which is the user array. And obviously later you can add here whatever entities you want, like maybe customers, products, articles, posts, or anything else. Now that we prepare a type for DB, we can create a DB manager. So the goal of DB manager is to manage our JSON file and parse it correctly. So it must get this file, read, and also write. This is why here we need two methods. First of all, we need here a getDB, which is an asynchronous function, and it will return for us a promise of db. Now here we can read a content of our file by calling fs, and we need to import it here on the top, fs from fs. We don't need to install any additional package, it is there by default in Node, and we can read here file by read file sync, and here will be a path db.json, and secondly it will be utf-8. And this content is a string, you can see it here. This is why we must parse it, because we want a JSON. So here let's call JSON parse and throw inside our content. And you for sure want to say, okay, but why we returned here a promise of DB and made our function asynchronous when it is really synchronous? We have read file sync and there is nothing asynchronous here. The main idea is that I'm making all our functions asynchronous, so you can easily swap them for the real database where all requests will be asynchronous. This is why it makes a lot of sense to plan our functions like that. And the second function that we need is update of our DB. So let's name it updateDB, and it is also an asynchronous function, and inside we want to pass a new DB. So we want to override our DB fully. And it must return for us a promise of void, so it returns for us nothing. And inside we can use fs write file sync, and here will be our file name db.json, and we want to use here JSON stringify, where we're throwing db inside, because for us db is an object. And as a third parameter we must provide utf-8. So now we have two functions which reads our file and updates our file. And the first request that we want to implement now is getting a list of users. We already created a route here, but we don't get this data from our database. How can we do that? All our database logic that is related to users we will write inside user database, which means here we want to create a new function findAll, and it must return for us all users from our database. This is why it will be an asynchronous function, and it must return a promise of user array. And in order to do that, we must first get a database. This is why here we can say that we are getting DB by calling await getDB. And this getDB function is coming from DB manager. This DB now, as you can see here, is typed. We know that the type is DB, and we can just return here db.users. So we're getting nice autocomplete, and we know that this findAll function returns for us an array of users. Now inside our DB, we can try and get users from the database. But as we're using an asynchronous function, it makes a lot of sense to wrap our code with try catch in case if we're getting an error. So here we want to get our array of users by calling await, and here will be our database. And in order to get all our database methods, I want to import here *as database from file user database. Now here we can wait for database.findAll, and it will return for us, as you can see here, an array of users. So after that directly we can respond with these users in our API. But what we are doing in catch, we want here to write res status, like 500, and then here will be some JSON, for example, an error that we got from the backend. This is totally fine that we're writing here 500 and it will work, but we can do better. There is a really nice library that I want to use here, and it stores enums, so we're leveraging TypeScript here with all status codes and messages. This is why in the console, let's install a library, http status codes. And now here on the top, we can import status codes from HTTP status codes. And instead of 500, we're writing status codes dot. And as you can see, we're getting an autocomplete for lots of different status codes. And we can write here internal server error. And when we're hovering here, we can see that this is just 500, but we're using here an enum and not some number. Let's check if this code is working. I'm hitting here send and we're getting an empty array. But now it is not just res JSON, this data really comes from our DB JSON. We can easily test that if we throw inside an object with ID 1, for example. Obviously this is not a correct user, but it is enough for a simple test. When I'm hitting here send, we're getting back an array with a single object with ID 1. Which means our whole logic with Database Manager and parsing our database works just fine. So we can remove this data from the users because it is not valid. The next request that we want to add is creating of the user or registration. But in order to do that, we need several helpers. First of all, we need find by email to check that such user email is not taken. And secondly, we need a helper function to create a user in our database. And both these functions we need to implement inside our user database. So first of all, here let's create a function find by email. And this is an asynchronous function where we're getting an email, which is a string. And back we're either getting a promise of user or null. And why null? Because if we don't find a user in our database, then we will return null. So in order to find the user from the database, we can first get all our users by calling findAll method. And then we can use find. So here let's try to find the user just by using users find. And here we have access to the user and we can compare that user email equals to the email that we provided. What I missed here is a wait, so our users was unresolved promise, now it is users array, and we're finding a user and we're getting back either user or undefined. This is why here directly we can return user or null, which actually means when it is undefined, we're returning null as we wrote in the return type. We successfully created find by email function, but in order to create a user, we need an additional type, because we don't have a type with the data that user provides in order to create a user. Let's have a look here inside types. We have the whole user, but it has ID. When we create a user, we provide just username, email, and password and not ID. This is why here I want to create a new type and name it unsaved user. And here we can use omit from TypeScript, where we provide user and ID. And what it does, it just generates a new type where it removes ID from the user. As you can see inside unsaved user, we're getting username, email, and password. So we could create it just like an object, but with a single line, we're reusing all this information. And if we're changing the user, we will change unsaved user accordingly. So our type is ready, now we can start creating our helper for the database. Let's create here a new function, create, which will be an asynchronous function, and here we're getting an unsaved user. And the data type here will be unsaved user that we just created, and back we're getting a promise of the user. And in order to create our user, we need one more library. It is called bcrypt, and we need it in order to hash our password. And again, as I already told you, you should never store just a plain password of the user. This is why let's jump to the console and install this package bcrypt, but we also need typings for that. So types/bcrypt. Now inside our create, we can generate a hashed password by calling await hash, and this hash function is coming from bcrypt, and inside we're providing unsaved user.password and also our salt. So hashed password will be just a string which is built from our password. Now here we can prepare our object, which is user to create, and the type here will be a user. So we can throw inside all fields of unsaved user and add here a password, which will be our hashed password. But it is not enough because we also need an ID. This is why we need to install one more package, which is called UUID, and we're using it to generate unique IDs for our entities. This is why here npm install UUID, and now here on the top we can import version 4 as UUID from UUID. And inside our create, we can also provide an ID and just call here UUID. This will be our unique identifier. So we successfully prepared our user object. We can even return our user here. But this is not enough because we did not update our database. And in order to update it, we first must read it, then update and save. So we can first get here db by calling await get db. We already did that. After this, we want to create a variable updated db, and this is just an object where we spread the whole db, and then we want to update our array of users. So how we update it? We're spreading here db users, so all users that we already have, and we throw inside user to create. In this case, updated db will be exactly our database. And we can just call here update db function that we created previously, and we throw inside updated db. Just to remind you, update db function just writes to the file the object that we are providing, which actually means in 3 lines of code, we can read db, update it, and then save to the file. So we successfully prepared types and methods to create a user. Now inside our user router, we can generate a new route for that. So user router post, and it will be /users. And here we will have an async function where we're getting access to our request and response. And we also need here try catch just like previously. So if we have an error, we want to throw an error just like we did before. So I will copy paste this line. But what about try? First of all, we want to read all necessary fields from the body. This is why here I want to destructure and get username, then email and password from request.body. After this, we want to check that all these fields were provided. This is why here let's check if we didn't provide a username, or we didn't provide an email, or we didn't provide a password. Then we want to return here res status. And here we're using status codes.badRequest. And just to remind, badRequest is 400. And we can provide here a JSON. And we can write here an error. Please provide all required parameters. So now we're safe that we have all these fields, and we need to check if we can use such email. This is why here let's try to get a user by calling a function database.findByEmail that we just created, and we're providing inside an email from our body. Now here again, if we find the user, we need to throw an error that such email is already used. So I will copy here an if and just change it. If we have a user, then it will be a bad request, and an error here will be this email is already been taken. Now we are protected and we can create our user. So let's create here our new user by calling our database method, which is create, and we're providing inside an object of username, email, and password. This will generate for us a user, and we can respond with this user. This is why res JSON, and we're throwing inside our new user that we just created. So now in Postman, we can do a request on /users. This is a post request, and inside body we want to provide first of all an empty body. I will hit send and we're getting an error, please provide all required parameters. This is exactly what we wanted, so we must provide an email, for example foo@gmail.com. Then we need here a username, which will be foo, and the last one will be password. Let's say 123. I'm hitting here send, and as you can see our user was registered, we got back an object with ID, which is auto-generated, and our password was hashed. Most importantly, we can jump to our db.json, and this is our user. As you can see, it was successfully added here, so it is already saved in our database. The next thing that we need to implement is logging to our system. And actually, we don't need any additional helper functions in our database. We can just create a route. This is why here I will copy-paste the whole user router post and just clean it. First of all, we will get a post request on /login, and instead of two fields, we are just reading email and password from the body. Additionally, here we also need a check for this email and password that they are there, and we are throwing please provide all required parameters if they are not provided. After this, we are getting a user by email. This is totally fine. And in this case, if we don't find the user, this is why here an exclamation mark, we can return here a not found status, it is 404, and write here an error, user does not exist. But after this code, we must do some changes. We don't need new user and REST JSON. We need to compare a password that we provided in our login, so here inside body, with the password of the user. This is why here let's create a variable is same password, and we're calling here a compare function. And this compare function is coming from bcrypt, and we must use here await because it is asynchronous, and we're comparing our password that we got from the body with user password, which is hashed. And now here I want to copy paste an if, and just check that if it is not the same password, then we want to throw bad request, and inside error we can write incorrect password. After all these checks, we can just respond in REST JSON with the user that we already have here, and we found it in this line, which actually means first of all we're checking for all required parameters, secondly that user with such email must exist, and then we're checking for the password. So let's jump to Postman and make a post request on /login, and in our body let's first check with just an email I'm sending, and we're getting please provide all parameters. Now here I want to provide an email which does not exist, like for example foo1. I'm hitting send. As you can see, we have some problem because here we're getting please provide all required parameters and not an error regarding email. So let's look in code. And as you can see here, I forgot to remove one bank. It should be if not email or not password. Let's check again. I'm hitting send, and now we're getting an error user does not exist because this email is not there. If the email is correct but the password is wrong, we're hitting send, we're getting incorrect password. And if everything is correct and we're hitting send, we're getting our user from the database. The next method that we need to implement for our TypeScript API is updating of our user. But in order to do that, we need a new type. By that, let's have a look on our types. We have unsaved user and we have user. And realistically, our changes to the user will be just these three fields, username, email, and password, but they will be all optional because we can change whatever we want. This is why here I want to create a new type, user changes, and here I want to use partial and then inside omit user ID. And the difference here is that all these fields now are optional and they can be undefined. But in our case with unsaved user, they are all mandatory. And this is exactly what we want because sometimes we need just to update maybe only password or only an email. So our data type is there now inside our database. We must create a function that will update for us a user. So let's create an update function, which will be an async function. And inside we will get first of all an ID of the user that we want to update. And secondly, user changes. This is exactly this data type user changes that we just created. And back what we want to get is a promise of updated user. But in order to write this function, as we're getting an ID inside, we need a function to get a user by ID. This is why here on the top, as we have find by email, I want to copy paste this function and create find by ID. We will get here instead of email an ID, and we also will return here user or null. Now here we need to find all users and compare the user ID with this ID that we provided. And this code is super similar, but it will find for us a user by ID. Now we can go back to our update function, and inside we can find a user that we want to update. So it is user to update, and we can call here our function find by ID that we just created, and we're providing inside an ID. It is possible that we don't find the user if we provided here a wrong ID. This is why we must cover it. If we didn't find user to update, we must throw an error here. So let's write throw new error. For example, user does not exist. After this, we have a case where we might update a password, but we might also not. This is why we must check that. What I want to do here, I want to create a let variable hashed password. And here I just want to store user to update .password. So this is our existing password. And now I want to write an if condition. So if user changes has a password inside, then we want to resave our hashed password. So I will override our hashed password. and just use here a function hash again, where inside we are providing user changes.password and also a salt, which actually means hashed password is just referencing our password, and if we wanted a new password, then it will be updated. After this, we can prepare our updated user of type user, and this is just an object where we can spread our user to update, so all fields of our current user, and we throw inside user changes, which actually means what we provide, we're just overriding. And the last one here, our password, which will be hashed password. So we either store the old password or the new one. And now here we need the same story like inside create, where we want to update our database. This is why I will copy these lines and paste after our updated user. So we're reading our database, then we want to update it. But here it will be slightly different because we want to update our array of users. And in order to do that, we want to map through all our users, and we can get access to every single user. And now we're checking, do we need to update a user or not? If our user ID equals user_to_update.id, then we're updating it. In other case, we can simply return a user. And how do we update it? We can just return here updated user that we created here on the top, which actually means inside this object we're throwing the whole DB, and for users we're mapping through all users, and we're updating just a single user that we want to update. After this, we're calling updateDB to write to our database. And as we actually wrote that we're returning a promise of the user, after this line we can return our updated user. So our helper function for the database is already there, but we need to create a router. And in order to do that, I want to copy-paste creating of the user because it is super similar. So let's paste it here on the bottom and change first of all a route. It will be not a post request but a put request because we're updating on /users/ and here is a dynamic ID. First of all, we want to get all these fields from our body, username, email and password, but we're not checking that they are there because they are not mandatory, so let's remove this if condition. Secondly, we want to find the user by ID. This is why here we can use find by ID function, and we're getting ID from the URL, so it is request params ID. Again, here if we don't have a user, we need to throw an error, for example, not found, because it means that we didn't find the user. So let's just write here not found. After this, we want to update the user, so as a result we will get here updated user, and instead of create we're just passing update, and here as a first parameter we can pass an ID, so request params ID, and as a second parameter the whole request body. This returns for us an updated user which we can respond with. Let's check this in Postman. We're doing our request on /users/ and here is an ID. We can copy the ID of our user from the response and use not post request but put, and we must update our body. What I want to change for my user is just a username. Let's write here that we want a username bar. I'm hitting here send, and this is what we're getting back. Our user was updated, the username is now bar, and this whole object looks correct. We can also jump in our DB.json, and as you can see here, our username was updated, which means updating of our user is fully implemented. And the last thing that we need to implement is removing of the user. And it is actually much simpler. Again, I want to copy-paste update function because it will be similar, but just smaller. Here, let's change it to remove, and we're removing the user just by ID, we don't have user changes. Back we're getting a promise of void because we don't have any result. So our first step is to get a user by ID, so we can write here user to remove, and then we're checking if we didn't find a user to remove, then we're throwing an error, user does not exist. After this, we don't need all this code with updated user, and we just start with reading our database and then creating an update DB. Instead of updating our users, we can simply remove a user from the array, and in order to do that we can write db_users filter, and we're getting access to every single user, and we're checking that the ID of the user does not equal the ID that we provided. This will update the database, and we're saving it here, and we don't really need to return anything because we have here a type promise void. Our database method is fully ready, so let's jump to the router and copy-paste our put. So it will be not put but delete method on /user/id, and here what we want to get is just an ID from params. So let's read an ID from request params ID, and now what we want to do is find our user. This is why here inside we can provide a user, and this is a user that we want to remove, and again we are checking if the user is not found, we are throwing an error, and after this, instead of this update user code, we can just call the function database.remove that we just created, and inside we are providing our ID. After we removed a user from the database, we need to respond with some status, so let's provide status codes OK, which means 200, and here we can provide a JSON with message user deleted. And I thought about one more thing. As you can see, when I'm jumping inside database remove, you can see that we already do the getting a user by ID and then checking that the user is not there, which means we're duplicating the code. We're checking for user to remove inside our helper, and also here we don't really need to do that. We can remove this code and simply read an ID and pass inside database because we're doing that check inside. Let's check if it's working in Postman now. We're doing a delete request on /user/end-id. We don't have any body. I'm hitting send, and we're getting a message user deleted. Now we can jump inside our db.json, and it should be removed. As you can see, it is not removed, which means we have some bug. Let's jump to user database, and as you can see here inside our updated DB, we did our filter wrong. Here we want to have a negation, so we want to leave all users except of the user that we are trying to remove, not vice versa. So here I put an exclamation mark, and let's check again. I'm hitting send, we are getting user deleted. Let's check now in our db.json, and now our database is completely empty, and we successfully removed our user. As you can see, creating TypeScript API makes a lot of sense, because we are leveraging here all these data types, and we are sure that our code is working. But if you're not sure that you know TypeScript on a good level, or you want to prepare for the interview, which includes TypeScript, I highly recommend you to get my free PDF, which I will link down in the description box below, and it covers all necessary knowledge that you need to know about TypeScript so you can prepare for your interview better.